In the elastic case, your relative velocities before and after are equal and opposite, both in the x direction and in the y direction. Same condition you have for one dimension. 2 dimensions is no harder than 1, just you got to do it twice. You got 2 dimensions. These equations are identical, except that this is the first mesh, that's u1x. This is the second mesh, that would be u2x. And then you combine that with this equation, and you get your solution. So I'm going to go ahead and do that. You got to go to class. The camera's on. I'll get it posted.
All right,
Yeah, you can walk right in front of the camera if you want. You can crawl on your hands and knees. You can vault over, or you can walk around the back. Your choice. You've already done it.
I feel like vaulting
Yeah,
would
you
be
got
too much of a show.
Okay.
All right.
I'll be around this afternoon if you want to come by, ask a couple more questions.
I probably will.
I'm not.
Okay? Good.
I mean, I like the subtle stuff.
Okay. So anyhow, just got rid of my class.
I mean, not saying I don't have a shirt with Matt Smith's face on it.
What's snow schedule?
But,
a little late.
I don't have a bunch of Dr. Who stuff, but
And
like.
my next class isn't here yet, so I've got to go ahead and see if we
Yeah,
can.
I love
Um,
the policy.
okay, so-
I've been meaning to pick it back up. The thing is, so.
Continuing analysis of this situation, assuming an elastic collision, relative velocity in the x direction is the same before, is equal and opposite before and after. Okay? Relative velocity before is equal and opposite to the relative velocity after. And the same for the y direction.
David
So-
Tennant, like, to me, or giants kind of vibe.
We
know,
have this
like,
equation,
self-
10 kilograms.
Humanity is actually great, and the individual can make a, good impact. And then with quality, y'all are putting grades, and I can't stand any of you. Like,
And
it
now we
makes
use,
sense,
instead
but I
of
don't like
ux,
the
we
direction
use
of that.
u1x,
And
because
it's
this is
just
mass 1.
disengaging for me.
It has a different after collision velocity than mass 2. That'll equal negative of 6 kilograms times u2x
That is true.
minus 9.6 meters per second.
I don't
This-
like, I also hate Moffitt.
Represents the impulse momentum theorem. You have equal and opposite impulses,
Yeah.
and these are the changes in momentum. They're equal,
The
and
first
because
couple
the negative sign, they're opposite.
episode.
The one antagonist that gets the
Neil's
least.
weeping
You also have,
versus
for the x
Moffitt's
direction, the
weeping.
v2x minus v1x,
I'm sorry.
u2x minus u1x.
Those concepts
Um,
were brilliant.
And then Moffitt took them and made them cynical, and they weren't cynical. Like the
They're
trapped in
just-
the spaceship and the weeping angels are like breaking people's necks, talking through their mouths. That's Moffitt's weeping angels. Don't blink is Neil's.
and that's not even written out correctly.
And don't blink even though it's.
So I'm gonna have to fix it. Well, we might as well do that on camera. Not having a great morning,
It.
no particular reason, weather. Had a string of those recently.
As well as, I'm trying to remember that.
Okay,
And what was the episode where all the
the
creepy
relative
children of the gas
velocity
masks- I'm trying to remember
before
what episode
collision
it was.
is
I know what you're talking about. I can, that was like Eccleston.
Yeah, that was, for me, that was the highlight of Eccleston's time.
Like something like the Doctor Dance or something.
v2x minus v1x. Is that what I have? And same for y.
Yeah.
Maybe I had it right. Let's make sure we explain it.
This is not aged gracefully.
Oh,
Yeah.
Okay?
In some parts you can just tell. that
Velocity of the second minus the velocity of the first before collision is the velocity of the second as perceived from the position of the first.
You had all of the ingredients there.
This would be the relative velocity after collision as perceived, again, from the position after collision of the first object.
You knew what worked about character.
And you got a
didn't
negative
work
sign.
about
They're
character.
equal and opposite. Actually, I think maybe I had it
Is
right.
that aforementioned?
Now, we're gonna plug in some numbers here. V2x and v1x are known. Okay, so we have v2x is 9.6 meters per second,
And I love the transition from Matt's
and v,
to Capaldi. goes towards the.
1x is 6.4
And then old decrepit man, the next dog.
meters per second.
Man.
equals a negative of
That concept. In his first few episodes.
u2x minus u1x.
Passing a physics sort of like.
Now we have
People are
two
cool.
simultaneous equations in u1x and u2x. Remember, we have four
Well, it was something.
variables here in the x direction, four velocities, two before and two after for the two masses. We've got to have enough information, one way or another, to be able to reduce the situation to equations in two of those unknowns. We can get two equations, one for the impulse momentum theorem, conservation of momentum, one for the way the relative velocities behave in an elastic collision. So we've got it here. We just have to do the arithmetic, solve this equation for either u1 or u2, plug it into this one, crunch the numbers. And we also then have the y direction, 10 kilograms times uy minus 4.8 meters per second. It's got to be u1y, because it's first mass 10 kilograms, minus the 4.8 meters per second. It's going to equal the negative of your 6 kilograms times, be careful to write things down right, u2y, because it's after collision, and it's the second mass, minus your negative 7.2 meters per second. Got enough parentheses there? I think I need another one. Close this one, close this one, close that one. Thought I'd closed enough of them over here, but I didn't. Okay. So, we also have v2y minus v1y, which is what? v2y is negative 7.2 meters per second, v1y is 4.8. So we have negative 7.2 meters per second minus 4.8 meters per second equals a negative of u2y minus u1y. Okay? And again, we have the same situation as before. We've got two equations now in the two quantities that remain unknown. And we can easily solve the equations. Okay, I'm not going to solve those equations right now because my class is late, snow schedule. One of them's coming from an hour away. One of them has to cut trees if there's an emergency. We had a little ice in the trees last night. They might well be occupied. But they might show up. So I want to go ahead and talk about what might happen if you're given slightly different information. So now you have the let's just say V1, and we'll go ahead and use the same 12 meters per second. At 53 degrees, as measured counterclockwise from the positive x-axis. V2 is going to equal 10 meters per second. I don't have an arrow over this because I'm not going to give you an angle. We're going to try to determine the angle. We're going to have sufficient information. The angle is one thing that we don't know, so we have an unknown there. Okay, so now I'm going to say that let's do it this way. Don't want to give you too much information, I'm doing this off the top of my head. Let's say that U1 is -4 meters per second at 133 degrees. Not sure I like that. That's a right angle with this. But we'll say it anyway. So there's your U1 and U2. Again, just a magnitude is 5 meters per second. I don't think I've given you enough information because in this previous case, we specified whether the collision was elastic or inelastic. But let's see what the status of our information is at this point. We know that V1x, well, it's going to be the same as before, but cosine of 53 degrees is 0.6. And that's going to be 7.2 meters per second. V2x is 4.8. Wait a minute, I got it wrong. Yeah, and it's, hang on. I'm trying to imitate what I did before, but I think I'm using different velocities. Yeah, that was 8 meters per second. Well, I'm just going to go with what I gave you, but I'll get the right numbers here. I think in the previous U2 was 12 meters per second or something. So it's going to be 9.6 meters per second. And this is going to be 7.2 meters per second. Calculated very easily in the direction of velocity. All we know is that V2 is 10 meters per second. What's that mean in terms of V2x and V2y? Well, by the Pythagorean theorem, take the sum of the squares of the x and y components, it's equal to the square of the velocity. And of course, square roots and stuff like that. So we can rearrange this in a number of ways. If I want to isolate V2x, I square both sides, subtract V2y squared from both sides, take the square root. I get the square root of 100 meters squared per second squared minus V2y squared. And I can use that in trying to solve my equation. So I have some information here. Okay. Now, in this case, same thing with U1 and U2. Okay, so U1x is going to be, I said -4 meters per second. That was a little silly, 4 meters per second. 133 degrees, just thinking reversing velocity and stuff. So, but at 133 degrees, the cosine is -0.8. That'd be -3.2 meters per second. And U1y is going to be -2.4 meters per second. Something's positive because you're in the second quadrant. Okay. And then we have this. Okay, so what's our status? Well, we can write down the same equations we have here, except for this equation and this equation, the impulse momentum equations. Then I haven't given you the masses. Make this 6 kilograms and make this, well, we use 6 and 10, but kind of reverse. Just because they're easy numbers to work with, okay? So we write down the equation for the change in momentum of the 6 kilogram object. And that's going to be 6 kilograms times, and we're going to do it in the x direction, okay? U1x minus V1x. That'll be equal and opposite to change in momentum, or the change in momentum of the second object, which will be minus 10 kilograms multiplied by U2x minus 5 meters per second. It looks like I made a mistake up here when I used 5 meters per second for the velocity of the second object. And I wrote something else down carelessly, so let's correct it. Hopefully that confused you for a minute, and hopefully this fixes it, because it's a pretty simple step. This should be 12 meters per second, because that's the velocity of this object, and this should be 10 meters per second, not the velocity of this object, okay? Or the speed. Okay, so we have this equation. Now, we're also going to have this equation. And I'm going to write it as this, just to get rid of that pesky square root sign. We're going to eventually have one anyway. And I wrote these equations down, I wrote them wrong. Writing a lot of things wrong here, so I'm going to trash this video.